Hello, this video is for our Math 161, both Monday, Wednesday, Tuesday, Thursday section. Tuesday, Thursday, you guys are watching this on March 26th, Thursday, and my Monday, Wednesday group, you guys are probably watching this on the 30th, week of 30th. But what you guys have in common, you guys have exam 2 coming up, and I did make exam 2 already on Alex. It's gonna have, well, I lowered it down to 24 questions, and I'm gonna look at it a little more, but I did create a bigger Unit 2 practice test. And in this video, I'm going to go over the practice test problems with you. Probably not all 27 questions in a single video, but I'm probably gonna divide it up to like 3 videos where I do about 9 of them in each videos. It will be given online, Alex. It will be given on Alex, but you will have to submit work, handwritten work, to show work on certain problems, okay? Not all 24 of them, because the actual exam will have 24 questions, but out of 24, I started typing up which ones I want the work. For example, I'm going to ask you to show work for, say, number 5, show step-by-step factoring work on number 5, or number 6, your horizontal asymptote and find the crossover point and show work for that. I mean, that direction is coming, but for this practice test, you don't have to submit any written work because we're doing this as a practice, as a review. So I know you are writing down work and you're not, because I actually want you to still do the math by hand. And I know there are a lot of online resources available that you can just basically type in math questions and they will answer it for you. But I tried my best to pick some of these items on your practice test and exam 2 where you will have to actually do some work on your own instead of just typing in answers onto these online calculators. So let's get started. Unit 2 practice test. You will take this on Canvas. I'm sorry, not Canvas, but on Alex. But in this video, I'm going to just go over a couple of problems that you will do, like a similar problem, because when you take this on Alex, they will change the numbers around. I'm going to go ahead and download a PDF of... Give me 1 second. I'm going to go ahead and download a PDF of this. I wonder how. I was able to do that on my computer. Print. I'm going to go ahead and print a PDF, and it gave me like 5 random. Let me go with number, like, let's say 5. I'm going to go with number 5, and I will post this PDF file on Canvas for you, so that you guys can, if you want to download it and follow along with this video, okay? So you will see this file already posted on Canvas by the time you're watching this video. I'm going to save this file on my notepad. But I just wanted to show you that I'm actually going to go over the practice test items with you in this video. Oh, so slow today. I'm going to create a new note, and I'll call this Unit 2 practice test. Okay, so I got it saved, and I'm gonna work on that now. Okay, now it looks like a 40-page document. Oh no, but I know what they're doing. It's got the answers in the back. See, these are all the answers all the way in the back, and I will also, I'll give you these. Page 1 through 24 is the problem, and from 25 all the way down to 40, these are going to be the solutions. And I'll give you these ones, okay? Because I know Alex will randomly generate each questions for you. I don't think you're going to get the exact same one, where all 27 problems are the same ones that I'm gonna go over. So anyways, this will be available to you on Canvas, but I'm going to go ahead and go over this note with you now, okay? So on my note, the practice test that I downloaded. All right. So my goal is to go over at least 9 of them in this video, and then I'll start another one where I go over the second 9 problems and then the last 9 problems. And after watching all these, or when you feel like you want to try some problems on your own, feel free to. I'll go to Alex and try this Unit 2 practice test. Now this you have 3 attempts, but I try to show you the same kind of test taking settings. So I did click on an option where I'm gonna ask you to be on a lockdown browser, or you'll see. But if you're having issues, you will know this week, and you will let me know, because your exam is gonna be next week. You will let me know if you're having any issue accessing your Unit 2 practice test, because if you're having issue today taking this on Alex, you will have issue when you're trying to take your real exam, which is going to be timed for 2 hours and 30 minutes. Okay, so I'm expecting all of you to take this Unit 2 practice test, which will count toward like a schedule knowledge or quiz grade. And all those are posted on Canvas. I talked about those on Canvas. So it's really important that you read all those directions for me or announcements for me. So on Tuesday class and Monday group, you are going to see something a little different. I have an announcement that says, please read important information regarding exam 2 next. Well, for this class, Tuesday, Thursday, it will be next Tuesday. But if you're in the Monday, Wednesday group, you need to go to your Canvas and read the announcements there. It's very important that you keep up with all these announcements that I post on Canvas so that you understand exactly what's going on, okay? But let me go back and do what I planned on in this video, going over some problems with you here. All right, consider the given function d of x equals 2x squared minus 12x plus 17. Now, it's got 9 parts to it. I think I counted 9 earlier. 1, 2, 3, 4, 5, 6, 7, 8. Well, just 8, huh? So 9 parts. And this is one problem where I will ask you to show work on part A and B. These are the 2 that I will ask you to show work on a separate sheet of paper, which you will scan and post on, submit on Canvas after you take the exam. And I know, like, you type in this into like an online calculator, they will give you all these answers. But I want to see you using the vertex formula. So here, start with B, identify vertex. Identify the vertex using the vertex formula. I do want you to use that formula, negative b over 2a. The vertex here, well, let's first identify our a, b, and c. A is 2, b is negative 12, and that's really all I need for right now, right? Okay, so let's find the vertex, the x-coordinate of the vertex. So negative b will be negative 12 divided by 2 times positive 2. We'll get positive 12 over 4. The x-coordinate is 3. So the vertex x-coordinate is 3. And the y-coordinate, you're going to have to plug it into the function. So find d of 3. That will be 2 times 3 squared minus 12 times 3 plus 17. This is something I will ask you to show work for. So this problem, when you are doing this on Alex, you need to show me your handwritten work. Okay, there are a couple problems where I will ask you to do that. Now this comes out to be negative 1, so we found the vertex to be 3, negative 1. Now, I know I wanted to do B first because I'm going to use this vertex to write the function in vertex form. So here we go. Writing this in vertex form, okay? And guys, I know you're taking this at home, so, you know, I'm not going to, like, tell you to, stop using your notes on it. If you want to use your notes on it, I think that's okay, because you're taking this at home anyways. But, because the ones that you're going to be able to do on these online calculators, I can't stop you from using them. It would be great if you don't use it and actually do your work. But to prevent everything going into those online calculators, that's why I'm asking you to show me some of these works. So A and B, if I don't see your work submitted, I will take away the points on your exam. So let's do this by hand. So the vertex form is y equals a times x minus h squared plus k. Now, this is from long time ago that we did, I think, sometime in March or April. Not April, February. But we do have all these values. Remember, h is the x-coordinate of the vertex. And k is the y-coordinate of the vertex, right? So, well, and we do know what a is. X-coordinate of the vertex is 3. We found that. And y-coordinate of the vertex is -1. And in fact, you identified what a is already. A is 2. H is 3. And k is -1. You have all 3 numbers that you need to write this equation in vertex form. So let's write that. So the vertex form will be y equals a first. A is 2. And inside the parenthesis, you will do x minus h. So that will be x minus 3 squared plus k. Well, I was going to do plus -1, but you can write that as -1, right? So we found the equation in vertex form. The vertex form is going to be this right here. Okay? We also find the vertex. So A and B, I do want you to show me work on your exam. In addition to you typing in the answers in these boxes. Okay? Now, this document is like 40 pages long because they use all these rooms. They're going to show you how you're going to type in your answers. But let's go back. C, D, E, F, G, and H. Okay. I think I'm going to go down. I'm going to go ahead and write this equation down on a separate sheet of paper so that I can just use the other pages to do part C through H. Okay? So give me 1 second. I'm going to go ahead and just take a quick picture of my of this equation. D of x equals 2x squared. This on my phone. Okay. So I'm going to go ahead and go to the second page or maybe the third page. No, it's the second page. So number 3 or part C is asking you to determine the x-intercept. Enter your answer as an ordered pair. If there is more than one answer, separate them with comma. Select none if applicable. Okay, so the equation was d of x equals 2x squared minus 12x plus 17. Now, to find the x-intercept, you set the y value equal to 0, right? Y equals 0. So set the entire function equal to 0 and do 2x squared minus 12x plus 17. Now, you have to solve a quadratic equation now. And we don't know if this is factorable. We don't know if this is factorable. So it will be great if it is factorable. But if it's not factorable, what do you have to do? You either have to use the quadratic formula and you have to, or you have to use completing the square. I'm going to take a look real quick. I don't think I want to give, well, why not? Let's review the quadratic formula and use it here. X equals negative b plus or minus big square root of b squared minus 4ac all over 2a. Now, you do know a is 2, b is negative 12, and c is 17, right? So we're going to plug in all these into our quadratic formula. So first, the numerator, I will have positive 12 plus or minus. B squared will be negative 12 squared minus 4 times 8 times c. And these are all getting divided by 2 times a, which is a. Now, you cannot see me using my calculator, but I will use my calculator to find this discriminant, okay? What I'm highlighting in yellow, this part, I'm typing that part into my calculator so that I can see what goes in my square root, okay? All right, negative 12 squared minus 4 times 2 times 17. That gives me 8. Oopsie. 8 divided by 2 times 2 is 4. Now, let's try to simplify this a little further because we can. 12 plus or minus. Notice that square root of 8 can be simplified into, well, I'll do the work right here. This is 4 times 2, right? 8 is 4 times 2. So that means square root of 4 will give me 2 outside. And we'll have 2 inside. So that will be 2 square root of 2 divided by 4. And now if you simplify this, I can divide 12 by 4 and 2 by 4. So this will turn into, well, I can't really divide all the way. So I can, well, all right, hold on. Let me just circle the numbers, circle all these 3 numbers, 12, 2, and 4. These are all divisible by 2, right? So I'll divide all of them by 2 and get my final solution of the x-coordinate to be 6 plus or minus square root of 2 divided by 2. So these are 2 x-intercepts. This will be nice to ask you to show me work because you will have to use the quadratic formula. Yeah, I'll do that. Okay, so they wanted what? Oh no, they wanted an ordered pair, didn't they? So guess what we have to do? We have to find the corresponding y values. But don't we know those already? We assume that the y values are 0. And in order for these to be an x-intercept, they better have a y value of 0, right? So without plugging in these x values, we already know the y's come out to be 0. So let's give them the x-intercepts. The x-intercepts are going to be 6 plus... Oh, let me write it maybe like above here, okay? Let me write it above here. A little bit bigger pen. All right, the first order pair is 6 plus square root of 2 over 2, comma 0. And the other one, separated by comma, they said 6 minus square root of 2 over 2, comma 0. So we found the x-intercepts. And for x-intercept, look, I had to use the quadratic formula because we wouldn't be able to get these x values by factoring, right? Completing the square is another option. But like, remember I suggested that the quadratic formula will be easier if the leading coefficient is greater than 1. So this is a great chance for me to ask you to use the quadratic formula. And this was given just right here, okay? Let's keep going. Part 4. This time, they want you to determine the y-intercept. Now, remember, y-intercept is the easier one. Y-intercept is the easier one. I'm opening my phone so that I can look up the function. The function is d of x equals 2x squared minus 12x plus 17. So in order for you to find the y-intercept, what do? You plug in x equals 0, right? So let's find that. Y equals 2 times 0 squared minus 12 times 0 plus 17. Now, these two just goes to 0, right? So the y-intercept is at y value of 17. So in an ordered pair, the ordered pair will be not 17. What's the x-coordinate, guys? I almost wrote the wrong order pair. X-coordinate is 0 and the y-coordinate is 17. So you must write down that the order pair is 0, 17, not the other way around, because if you enter the other way around, it will be marked wrong. Of course, I will go back and check your answers that you submitted on Alex to see if I can get some partial credit. But I can see someone getting this wrong if they accidentally type in 17, 0 instead of that. So you just want to be careful, right? Not that one. It's going to be this. Okay? All right. So y-intercept was much easier. Let's keep going. Oh, now we're going to sketch the function. Now, what I suggest you do is you do have a graphing calculator. Use it. In a timed test, you want to use all these, approved technology like TI-84 graphing calculator. If you have it, try to use it. And let me write down the function, which was d of x equals 2x squared minus 12x plus 17. And let me write down what we know already, the vertex. The vertex, we got it to be, guys, I forgot. Let me go up and look it up. The vertex was at 3, -1. 3, -1. And I remember the y-intercept that I just found was at 0. 17, right? 0, 17. And you should be able to plot specific points by using a tool on Alex, but we can put another points. But let me start with this point first, okay? Oh, unfortunately, my graph doesn't go all the way up to 0, 17. So this Y-intercept, although we found it, it's not really going to be any use for us. All right, let me plot the vertex first. 3, negative 1. 3 to the right, down 1. Here's my vertex. And what I suggest you do is you graph the axis of symmetry. You may not want to enter that on Alex, but this will help us graph a function. So what I know, I'm going to go ahead and find an XY table, and we're going to need at least about 5 points to graph this beautiful curve. If I can fit all 5 points, that will be great. I know 3, negative 1 will be my center or the vertex. I want to find something to the right of it, so I'll go 4 and 5. And I want something to the left of that point, so I'll go 2 and 1. Well, we know what we're going to do is we're going to use the axis of symmetry and the symmetry idea to graph other points. I'm just going to do 2 more points here, okay? So plug in 1 into the function. What is d of 1? That's going to be 2 times 1 squared minus 12 times 1 plus 17. That's going to be 2 minus 12 plus 17. And 2 minus 12 plus 17 is 7. So we have a point at 1, 7. Let me do one more. D of 2. 2 times 2 squared minus 12 times 2 plus 17. My dog is snoring so loud. Go sleep somewhere else. Go. All right, what's that going to be? 2 times 2 squared minus 12 times 2. I'm typing this into my scientific calculator right now, guys. And that came out to be 1. All right, so what I'm saying is that's enough. That's enough for you to graph this function. This looks like 7. Hold on, let me just... Ooh, whoopsie. I deleted the whole thing. This is 1. Let me plot 1, 7 on my graph. 1 to the right, up 7. Here we go. Now, using this symmetry, what I know is that, well, this point is 2 to the left of my axis of symmetry. I'm going to have a point that is 2 to the right of that point. So we know that we're going to have a point at 5, 7. So these two will be symmetric. 5, 7 is another point that I have. 2, 1, let's plot this one. 2, 1. 2 to the right, up 1. If I have a point right there, then using the symmetry, I'm going to go 1 to the right of that axis of symmetry and plot another point at 4, 1. And as you can see, we'll be able to use this nice axis of symmetry idea to graph a function, right? So let's go ahead and sketch a nice curve. Sketch a nice curve. And that's how you can sketch this function. All right, moving on. Step number 6. They want you to determine the axis of symmetry. The axis of symmetry, well, we just graphed it, didn't we? We just graphed that axis of symmetry right here. But you do want to enter this as an equation though, right? You're not going to just say a single number, 3. You're not just going to say 3. The axis of symmetry is a vertical line. So you should say x equals 3 for your answer, okay? And remember, we talked about how axis of symmetry, if you look at this word carefully, there it is. They said x is. So you want to use the x-coordinate of the vertex, and the x-coordinate of the vertex was 3. Now, you can use that formula, x equals negative b over 2a, and that's going to give you the axis of symmetry. But since we already got everything graphed, I was just able to read it, okay? All right, step number 7. They want you to determine the minimum or maximum value of the function. Now, let's take a look at the graph, okay? The graph is a nice parabola opening upward. So we do have a minimum. We have a minimum. Well, I'll say minimum point at 3, negative 1. So when they ask you for the minimum value, remember, they're asking you for the y-coordinate, right? So the minimum value is at negative 1, which is the y-coordinate of the vertex. Okay? So let's say, G, determine the minimum or maximum value of the function. D has a, I will say, minimum value. And part 8 is asking the minimum value D is -1. So they were kind of going together. And minimum value is, or if it's a maximum, I mean, if you get a graph that's opening upside down like that, then you will have a maximum. But to find that value, you just have to go with the y coordinate of the vertex, okay? So remember that. All right, we are almost done with number 1. Number 9 now. They want you to find the domain and range of this interval notation. Now, a quick sketch of the graph that I'm about to just copy down here. 3, -1 was the vertex, right? And the graph kind of looked like that. Remember, domain of any quadratic function, we talked about this in class, is going to be all real because there's no restriction on what kind of numbers we're allowed to square. X can be any number to the, to positive infinity, and X can be anything to the very small number. Quadratic function's domain is always going to be -infinity to positive infinity in interval notation. But remember, the range, we have to be careful. How low does this picture go? The lowest point of this graph is -1, right? But we do have a point at -1, so make sure you draw a square bracket. And notice this graph goes up forever, right? Therefore, the other side is going to be positive infinity. So that's how you can tell the domain and range of this function. Now we're done. Now we're done with that. Number 2, we're going to keep on going. I think the first couple will be quadratics. And I think the first couple ones are the multi-step parts, like multi-parts. Ugh. So maybe after example 2, I'll stop the video and come back and record a couple more. I can see question number 3 is a short one. Question number 4 is a short one. But I think it will be a great time for me to take a little break after number 2. Okay? All right. But this one will go much faster because, look. Oopsie. This is given in vertex form already. This is already in vertex form. So what's really good about vertex form? Well, you look at it, you will be able to tell what the vertex is immediately. Now remember, vertex form is y equals a times x minus h squared plus k, right? And vertex is hk. So if they ask you for the vertex, all I need to do is just read what h and k is. But A, they're first asking whether this parabola opens upward or downward. What do you think? In order for you to tell whether it opens upward or downward, you have to look at the A value. Notice A is negative, right? So, because A is negative, since -3 is negative, or just say A is less than 0, we know this graph will open. G of X opens downward. Okay? This is going to be one of the easiest problem on your or test, right? You just have to look at the A value. If it's positive, it's gonna go open up. If it's negative, it's gonna open downward. All right, let's do identifying vertex. Okay, take a look. I'm highlighting the H and K. H is 1, and K is 12. No. I'm saying this wrong. Remember that you have to use the opposite sign when you see. Find the x coordinate. And we talked about this in class a long time ago. So hopefully you still remember this. The y coordinate is going to be 12. But notice that we have to see it as x getting subtracted. So think of this as x getting subtracted by -1, which turned into x plus 1. So h value is really -1 here. H value is -1. So the vertex is going to be -112. If I'm making a couple other examples here, for example, what if you have something like y equals 3x plus 7 squared minus 7? Say that you have this function, a completely random one that I just created. The vertex will be at -7, -7. Another one, what if you have y equals 5x minus 3 plus 2? The vertex will be at where? The vertex will be at +3, 2. So remember, to find the x-coordinate, you will almost have to, you're going to have to take the opposite sign of what you see inside. If you see a +7 inside, then the x-coordinate will be -7. If you see -3 inside, the x-coordinate will be +3. But the y values are exactly the same. And why was this true? Let's think about the transformation, right? Adding 12 will move the graph up 12 units, right? But, well, adding 1 inside, this will move the graph left 1 unit. So if you go 1 to the left from the 0, you will be at -1. So that's why this inside kind of works backward, and that connects with what we talked about in Unit 1, the transformation lessons. But let's keep going. Let's keep going with the other parts. Now, I'm going to take a picture of my equation because I'm going to go to the other pages to do all the other parts. Oopsie, sorry. Everything's getting submitted today. All right, so C through H, I will work them out on the other pages. And I will also scan this document and post it on Canvas in case you rather just read through instead of watching a long video. All right, we did vertex. Let's do the X-intercept. The equation was, let me write it down. Y or g of x equals -3 x plus 1 squared plus 12. Now that was the equation. Now if you want to find the y-intercept, I'm sorry, well they want the x-intercept this time. X-intercept, then what do? You set y equal to 0, right? And y is the function value, so you're going to say 0 on the other side of this equal sign. Replace g of x by 0. Copy down this side. And let's solve this for x. What do we do to both sides first? Remember, we're going to subtract 12 from both sides. -12 equals -3 times x plus 1 squared. Now, I'm not going to FOIL this. I'm not going to do any of that. What I'm going to do here is I'm going to divide both sides by -3. Then I will get +4 equals x plus 1 squared. Now, I'm going to borrow the room for part, down here because I want to keep on going. But what will you do to both sides at this point, guys? You will take square root, right? If you take square root, we're not going to get just +2. We're going to get plus or -2 equals x plus 1. Now, this is where we're going to have to separate these two into x plus 1 equaling either +2 or x plus 1 equals -2. All right, let's solve for x values. Subtract 1 from both sides. The first x-intercept is at +1. Subtract 1 from both sides. The second x-intercept is at -3. So we have two x-intercepts, and we do know the y value already. The y value to be an x-intercept, it must be 0. So let's write the order pairs. The first order pair is 1, 0. The second order pair is -3, 0. I'm excited because these are very good points for us to graph. So later when we are graphing, we should be able to use these two x coordinates, okay? All right, let's determine the y-intercept. Y-intercept is, let me just use this tiny room over here, okay? Y-intercept is when x value is equal to 0. And we do know the function here. So we're just going to go ahead and rewrite this and replace the x by 0, okay? So y is going to be -3 times 0 plus 1 squared plus 12. What's that going to be? -3 times 1 squared plus 12. I'm going to get -3 plus 12. So the y-intercept is at 9. What's the order pair then? Order pair, we must use the x value and y value. We do know x is 0, y is 9. So the order pair will be 0, 9. Now, that's another great looking point for me to plot. So I'm excited to graph this function soon. So let's keep going. Let's go to part 5. They want us to graph this function now. Let me go ahead and write down everything we know so far, okay? So g of x is -3 times x, I forgot. X plus 1 squared plus 1 squared plus 12, okay? And we found that the vertex was, using the answer that we got from above, -1, +12. We got the Y-intercept to be 0, 9, right? I believe that was it. 0, 9. Yes. And what were the X-intercepts? 1 and -3. X-intercepts are 1, 0 and -3, 0. So these are just the answers that we got from the previous parts. So I'm going to go ahead and plot all these. But first, what is the very first points that you always want to plot when you're graphing a parabola? The vertex, right? So plot the vertex at -1, +12. Right here. And I'm going to use the axis of symmetry later to graph this. Now, let me go ahead and do my Y-intercept of 0, 9. 0, 9. So here's my first Y-intercept. Notice I have a point 1 to the right side of that axis of symmetry. So I'm going to have another one right here. Now, what were the other two X-intercepts? The X-intercepts were 1 and -3. So I can just plot those. 1 and -3. 1, 2, 3 to the left. Perfect. So it's a very, very skinny parabola opening downward because remember the leading coefficient was -3. It's going down rapidly. All right, let me go ahead and sketch a nice curve using these 5 points. And as you guessed or as we answered above already, this graph is opening downward, right? All right, so we graphed that one. I'm going to have, as you saw, number 1 was given in standard form. Number 2 is given in vertex form. I'm going to have one of each on your exam too. And I want you to be able to work with both forms, okay? All right. F. Determine the axis of symmetry. Oh, we already found that earlier. The axis of symmetry is really the x-coordinate of the vertex. And the x-coordinate of the vertex was -1, right? So x equals -1 is what you want to type in, okay? Determine the minimum or maximum value of the function. Now, minimum or maximum value of the function happens at the y-coordinate of the vertex, right? Now, let's see. What is the highest point of this parabola? You can see that the highest point of this parabola is right here. This is the maximum. And maximum is happening at -1, 12. That means the y-coordinate, 12 is as high as this graph goes. So, write down that function has a maximum value. And on Alex, you're just going to have to choose from this drop-down menu. And step 8, part 8 is asking, what is that maximum value? And remember, that was 12, right? Now, we can use this to find the domain and range, or just the range part, because you do know the domain is automatically what? Domain of this function is automatically -infinity to +infinity for any quadratic function, okay? And the range, though, you have to be careful. Quickly kind of sketching this graph. Remember, the graph was going down forever to the bottom, right? So you can say -infinity for the first position, but notice the highest point that this graph is going to touch is 12. So the y-coordinate will be 12. The highest point will be 12, but because we have a point at 12, make sure you draw a square bracket. Now, that was a great first 2 problems. Whew, I really did like 18 problems, didn't I? But I think they can go really quick. I'm just talking through this. That's why it's taking longer time. But after watching 1 and 2, taking some good notes, I want you to use those notes on your practice test. Okay? I'll come back and do the other parts. So question 3, question 4. The rest are going to go a little bit faster. But then the first 2 was kind of long, I agree. So I'm going to stop the video now and come back with a couple more videos.